Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A 3 a.m. support ticket says the app is down, but EC2 instances are healthy, the database is responsive, and logs are clean. The actual culprit is a stale Route 53 DNS record sending traffic to the wrong IP address, so users get errors before a single request touches your VPC. Last time, we covered Internet Gateway versus NAT Gateway, how traffic leaves and returns to your VPC, but none of that matters if DNS doesn't work first. DNS is the Internet's phonebook. It turns example.com into a numeric IP address like 192.0.2.1. Route 53 is AWS's managed DNS web service for that translation. By the end of this video, you'll be able to explain Route 53's 3 core functions, choose the right routing policy for a given scenario, and configure a health check and failover record in the AWS console. Write those down. They're the 3 things that show up repeatedly on the exam and in job interviews. Here's the general flow of DNS resolution. You type a domain name into a browser, and your device asks a recursive resolver to find it. The resolver walks through several layers of DNS servers until it reaches an authoritative DNS service, like Route 53. That service holds a hosted zone, which is the container of DNS records for your domain. It returns the IP address for the name, and your browser then connects straight to that IP. If you run one DNS server in one data center, that server is a single point of failure. Power outage, network cut, misconfiguration, your domain stops resolving. Route 53 avoids that by using a global anycast network. The same DNS server IP address is advertised from many edge locations, and each query is routed to one nearby location. If that location fails, routing shifts to another. That's why a self-managed single DNS box feels fine until the night it isn't. Quick checkpoint before we unpack each one. What are the 3 primary functions of Route 53? Give yourself a beat. If you said domain registration, DNS routing, and health checking, you're ready to dig into the first one. Before we go deeper into Route 53, learn one troubleshooting distinction that can save you hours. A user says, "The website is down." Is that automatically a DNS problem? No. Start by testing name resolution. Use a tool such as NSLOOKUP or DIG and ask DNS for the application's hostname. If the name does not resolve, returns the wrong destination, or points to an old endpoint, investigate the DNS path. Check the hosted zone, the DNS record, name server delegation, and whether an older answer may still be cached. But suppose DNS returns exactly the destination you expected. At that point, Route 53 may have already done its job. Now, troubleshoot the connection. Can the client reach the destination? Is the route correct? Do the security group and network ACL allow the traffic? Is the load balancer healthy? Is the application listening on the expected port? This gives you a troubleshooting sequence worth remembering. Resolve the name, verify the destination, test the connection, check the application, and remember the boundary. Route 53 helps clients find the destination. Your network and application still have to make that destination reachable and functional. Separating DNS resolution from network connectivity, prevents you from changing DNS records to fix a problem that was never DNS in the first place. Picture this. It's Monday morning and users say the company website is gone. The EC2 instances are healthy. The load balancer is healthy. Nothing changed in the application. Then someone checks the domain registration. It expired. Domain registration is an operational dependency just like servers, certificates, and network connectivity. If the registration expires or its configuration is mishandled, users may lose access even when the entire application stack is healthy. Route 53 can centralize domain registration and renewal management in AWS, and automatic renewal can reduce the risk of someone forgetting a date on a spreadsheet. But don't treat automatic renewal as magic. Organizations still need to maintain accurate registration information, valid payment details, appropriate account access, and monitoring around critical domains. The lesson is bigger than Route 53. Your domain is production infrastructure. Manage it like production infrastructure. When you register or transfer a domain in Route 53, much of the DNS setup is handled for you. Route 53 can create the hosted zone and populate the DNS records that delegate authority and hold zone metadata, so you don't have to hand-edit name server entries. The key benefit is fewer manual steps and fewer opportunities to make a mistake. There are two separate decisions that people accidentally blend together. Registrar means who manages your domain registration, renewal, and registrant information. DNS hosting means who answers DNS queries for that domain. Registering a new domain with Route 53 makes Route 53 the registrar and creates a Route 53 hosted zone by default. Transferring an existing domain moves the registration from one registrar to another. But a registrar transfer does not automatically mean you must move DNS hosting too. You can register a domain with Route 53 and keep DNS at another provider. You can also register a domain elsewhere and use Route 53 for DNS. To make Route 53 authoritative for the domain's name servers must point to the name servers in the Route 53 hosted zone. That is the setting that moves DNS answers to Route 53. Let's register a domain in the Route 53 console. Open Domains, choose Registered Domains, then select Register Domains. Search for the name you want, add an available domain to the cart, and proceed to checkout. Choose the registration term. Decide whether to enable automatic renewal, and enter the required registrant contact information. Registration and renewal have costs, and Route 53 also creates a hosted zone with its own monthly charge, so check current pricing before you submit. When registration completes, Route 53 creates a hosted zone for the domain. That zone includes the NS and SOA records. The NS records identify the Route 53 name servers that answer authoritatively for the domain. The SOA record holds zone metadata. If you use a different DNS provider later, change the domain's name servers there. If you create a replacement hosted zone in Route 53, update the domain to use the name servers assigned to that new zone. Quick checkpoint. After you register a domain in Route 53, which DNS record types get created in the new hosted zone, and why do name server updates matter? Give yourself a beat. The answer is NS and SOA records. The NS records delegate authority, so queries resolve through Route 53's name servers. Now the split that confuses people: public versus private hosted zones. A public hosted zone contains records for names that should resolve on the open internet, such as a customer-facing application. A private hosted zone contains records that resolve only inside the VPCs associated with that zone, such as an internal service name or a database host name. But keep the boundary clear. A private hosted zone controls DNS resolution scope. It does not make a resource private by itself. Routing, public IP addresses, security groups, and network ACLs still decide whether someone can actually reach that resource. The key idea is simple. Public hosted zone means public DNS answers. Private hosted zone means VPC-scoped DNS answers. Neither one replaces network security. A lot of people picture a hosted zone as a server they have to manage. In Route 53, a hosted zone is the container that holds your DNS records. You edit records, and Route 53 handles the actual resolution. So your job is record management, not server administration. Now the record types you will actually encounter for the Cloud Practitioner exam. An A record points a name to an IPv4 address. An AAAA record points a name to an IPv6 address. A CNAME record points one DNS name to another canonical DNS name. An MX record identifies mail servers. A TXT record holds text data, often for domain verification, SPF, DKIM, or other email security settings. Then there is Alias. Alias is not a standard DNS record type. It is a Route 53 specific option that lets an A or AAA record point to selected AWS resources, such as an application load balancer or CloudFront distribution, or to another eligible Route 53 record in the same hosted zone. In practice, the records you will see most often are CNAME, MX, TXT, and Route 53 alias records. This is the classic Cloud Practitioner trap. CNAME versus Alias. A CNAME is a standard DNS record that points one DNS name to another DNS name. You cannot create a CNAME at the zone apex, the bare domain, such as example.com, because that name also needs other records like NS and SOA. Alias is a Route 53 specific extension. It can point to selected AWS resources, including load balancers and CloudFront distributions, and in most supported cases, you can use it at the zone apex. Route 53 resolves the alias target and answers with the applicable A or AAAA data. So when an exam question asks how to point a bare domain to an AWS load balancer or CloudFront distribution, Alias is the record to consider. For a generic DNS name outside the supported alias targets, use CNAME at a subdomain such as www.example.com. Quick checkpoint. Which Route 53 record type is commonly used to point a domain at AWS service endpoints and is often the pick for bare domain scenarios? Here's the situation. Your app runs in Ohio, London, and Tokyo, but users type the same domain everywhere. You need a way to decide which backend each user should reach. Route 53 can return different answers for the same domain name depending on rules you configure. A routing policy is just a rule that helps Route 53 choose which address or addresses to include in a DNS response. The next few scenes are different answers to the same question. Which address do I hand this user? Start with the simplest routing policy. Simple routing. Suppose appexample.com has one backend endpoint. You don't need to split traffic by percentage, choose a region based on latency, or maintain a primary and secondary failover design. You simply need DNS to return the configured destination. That's where simple routing fits. You can configure a simple record with one or more values, and Route 53 can return those values in DNS responses. But here's the important design lesson. Simple routing does not give you the routing behavior we're about to build with policies such as weighted, latency, or failover routing. Need to gradually shift traffic between versions. Think weighted. Need to choose among AWS regions based on latency? Think latency. Need an active-passive primary and secondary architecture? Think failover. Simple routing is the baseline. The other routing policies exist because real architectures often need more decision-making than simply returning the configured DNS answer. Weighted routing lets you assign relative weights to different endpoints, so one endpoint can receive proportionally more traffic than another. For example, you might set one endpoint's weight higher than another's, and Route 53 will use those weights to influence how often each address appears in responses. The distribution is approximate, not a strict round-robin. Use weighted routing when you want to gradually move traffic from an old backend to a new one, or send a small slice of users to a test version. Here is the twist with latency routing. It does not pick the region that looks closest on a map, and it is not a live speed test from every individual browser. Route 53 uses its latency information to choose the AWS region that provides the best latency for the DNS requester. That means a user in Singapore might receive Tokyo instead of the geographically nearest endpoint if the network path to Tokyo performs better. A user in Frankfurt may often receive an endpoint in Europe, and an Ohio user may often receive one in the eastern United States. Physical distance influences latency, but it does not decide it by itself. Network paths and measured latency matter. Checkpoint. Which Route 53 routing policy sends each query to the endpoint with the lowest network latency for that user? The answer is latency routing. The key is measured network latency, not map distance. Failover routing is Route 53's active-passive pattern. A health check monitors your primary endpoint. While the primary is healthy, Route 53 returns the primary record. When that health check becomes unhealthy, Route 53 starts returning the secondary record in new DNS answers. But DNS is cached. Recursive resolvers and client devices may keep the old answer until its TTL expires. That means DNS failover is not an instant disconnect from the unhealthy endpoint. The health check triggers the DNS change, and TTL plus resolver caching shape how quickly users see the recovery. Lower TTL values can shorten the caching window, but they can also increase DNS query volume. Health checks, DNS TTL, and endpoint recovery all work together in a real failover design. There are two common availability patterns to know. Active-passive uses Route 53 failover routing. One primary endpoint serves traffic, while a secondary endpoint waits for the primary health check to fail. The secondary is your standby capacity. Active-active keeps multiple endpoints serving traffic at the same time. You usually build that pattern with weighted routing, latency routing, or multi-value answer routing, often combined with health checks, so Route 53 stops returning unhealthy endpoints. The difference is simple. Active-passive keeps capacity in reserve. Active-active uses capacity in more than one place all the time. A health check is Route 53's way of asking whether an endpoint is alive and responding as expected. For an endpoint health check, Route 53 sends automated requests over the internet at the interval you configure, typically 30 seconds or 10 seconds for fast checks. If the endpoint stops responding correctly, Route 53 marks the health check unhealthy. You can monitor that status with CloudWatch and use it with DNS routing policies to stop returning unhealthy endpoints. One important limitation: Route 53 endpoint health checkers are outside your VPC, A private IP address inside a VPC is not directly reachable by those public checkers. For a private workload, use a public health endpoint when appropriate, or use a CloudWatch alarm health check based on an internal metric. Monitoring is the prerequisite for automatic DNS failover. No health signal means Route 53 has no evidence that the primary should be removed from new DNS answers. Route 53 health checks come in several useful forms. Endpoint health checks monitor a public IP address or domain name by making automated requests over the Internet. Use them when Route 53 can reach the endpoint directly. Calculated health checks combine the status of other Route 53 health checks into one overall decision. Use them when an application depends on several components and you care whether a minimum number of those components remain healthy. CloudWatch alarm health checks use the data stream and criteria behind a CloudWatch alarm. They are useful for private resources, application error rates, or service metrics that an external probe cannot see. Use endpoint checks for public reachability, calculated checks for combined dependency logic, and CloudWatch alarm checks for metric-driven or private resource health. Quick checkpoint on health checks. Which type of Route 53 health check should you use when your app depends on several components and you need one overall go or no-go decision? You can also create a health check with the AWS CLI. Start by defining the endpoint, protocol, port, path, and failure threshold in a JSON file. The endpoint must be publicly reachable if you are using an endpoint health check. Save the following as healthcheckconfig.json, then replace the documentation address and path with your own public test endpoint. JSON, IP address, 203.0.103.10, port 443, type, HTTPS, resource path, health, request interval, 30, failure, threshold. 3. Then run this command. Change the caller reference to a unique value in your environment. Route 53 uses it to recognize repeated create requests. Bash AWS Route 53 create health check jars. Caller reference. Route 53 video demo U22608 wait. Yars. Health check config file. JH health check config JSON. For a private workload, do not point an endpoint health check at a private IP and expect Route 53 to reach it. Use a CloudWatch alarm health check or expose a deliberately designed public health endpoint instead. Inside the Route 53 console, create the health check first. Then open the hosted zone and create 2 records with the same name and type, using the failover routing policy. Create the primary record for the normal endpoint and associate it with the primary health check. Then create the secondary record for the recovery endpoint. Route 53 now has the active-passive pair it needs. When the primary health check becomes unhealthy, Route 53 begins returning the secondary record in new DNS answers. Remember that clients and recursive resolvers may still use the primary answer until its TTL expires. So test with a short, deliberate TTL and allow time for cached responses to age out. Before using this in production, confirm that both endpoints can actually serve the application and that your health check validates the part of the service that matters, not just whether a TCP port is open. DNS security gets confusing because AWS has several features that sound related but solve completely different problems. So don't memorize the names first. Start with the problem. Problem 1. A workload tries to resolve a malicious or prohibited domain. Think Route 53 resolver. DNS firewall. DNS firewall filters. DNS queries handled through Route 53 resolver based on the domain rules you configure. You can use it to block known malicious domains or restrict which domains workloads are allowed to resolve. But remember the boundary. DNS Firewall filters DNS queries. It is not a replacement for security groups, network ACLs, or application layer security. Problem 2. You want to protect DNS queries while they're traveling between a resolver client and a Route 53 resolver endpoint. Think DNS over HTTPS, or DOH. DOH encrypts that DNS traffic in transit, so the query is not traveling as traditional unencrypted DNS between those components. Problem 3. You want a validating resolver to detect forged or modified public DNS answers. Think DNSSEC. DNSSEC uses cryptographic signatures so validating resolvers can verify the authenticity and integrity of signed DNS data. So don't memorize 3 random AWS features. Remember 3 problems. Control which domains can be resolved, DNS Firewall. Protect DNS queries in transit, DOH. Protect the integrity of public DNS answers, DNSSEC. Different threats, different controls. Traffic flow is the visual editor for complex Route 53 routing policies. Instead of hand-editing dozens of related records, you can drag endpoints and routing layers onto a canvas, connect them, and create a traffic policy that represents the record tree. Traffic flow can create the underlying records automatically when you create a traffic policy record in a public hosted zone. It also gives you versioning. When you change the design, you create a new policy version rather than silently changing the old one. Then you choose which traffic policy records to update to the new version. Route 53 updates the dependent record tree for those selected records, and you can roll back by assigning a previous version again. That is what prevents drift, visual relationships, versioned changes, selective rollout, and rollback. Remember that traffic flow has charges for traffic policy records, so use it when the routing complexity justifies it. Quick checkpoint before the exam sweep. Which Route 53 feature blocks lookups to known malicious domains? The CLF-CO2 exam doesn't just test whether you recognize Route 53 terminology. It tests whether you can separate concepts that sound similar. Here are the distinctions worth drilling. Public versus private hosted zones. A private hosted zone controls where DNS names can resolve. It does not make the underlying resource private. Routing, addressing, security groups, and network ACLs still control whether that resource can actually be reached. CNAME versus Alias. A CNAME points one DNS name to another DNS name, but you cannot place a CNAME at the zone apex, such as example.com. A Route 53 alias can point supported record types to selected AWS resources and can be used at the zone apex in supported scenarios. So if an exam question asks how to point example.com directly at an application load balancer or CloudFront distribution, think alias. Simple versus advanced routing policies. Simple routing is appropriate when you don't need routing decisions such as weighted traffic distribution, latency-based selection, or active-passive failover. If the question says, send 10% of traffic to the new environment, think weighted. If it says, send users toward the AWS region offering better latency, think latency-based routing. If it says, primary and standby, think failover. Health checks versus instant failover. A health check can cause Route 53 to stop returning an unhealthy endpoint when the routing configuration uses that health information. But DNS answers are cached, so clients may continue using an older answer until its TTL and other caching behavior allow them to retrieve a new one. And finally, registrar versus DNS hosting. Moving a domain registration to another registrar does not automatically move authoritative DNS hosting. Those are separate decisions. If you can reason through those distinctions instead of memorizing isolated definitions, you're ready for the Route 53 questions that try to give you two answers that both sound correct. Now let's see if you can design with Route 53 instead of just defining it. Your company runs the same application in two AWS regions, one in Northern Virginia and one in Oregon. Both regions are active. You want users to receive the endpoint that provides the better network latency. But there is one additional requirement. If an endpoint becomes unhealthy, Route 53 should stop returning that unhealthy endpoint in new DNS answers. What would you build? Start with the routing requirement. You want users directed based on network latency, so choose latency-based routing. Create latency records for the application endpoints in both AWS regions. Now add health awareness. Configure the appropriate health evaluation so Route 53 can determine whether an endpoint should continue participating in DNS responses. If the Virginia endpoint becomes unhealthy, Route 53 should stop selecting that unhealthy record for new answers and direct eligible users toward the healthy endpoint. But remember what you learned earlier, DNS answers are cached. Even after Route 53 changes which record it returns, recursive resolvers and clients may continue using an older cached answer until its TTL expires. So the complete design isn't just latency routing. It's latency-based routing, plus health awareness, plus a deliberate TTL strategy. That's how Route 53 turns DNS from a static phonebook into part of a resilient multi-region architecture. Before we finish, here's the answer you should be ready to give in a job interview. The interviewer asks, "What is Amazon Route 53?" Don't stop at, "It's AWS DNS." Give them this. Amazon Route 53 is AWS's highly available DNS service. It provides capabilities including authoritative DNS, domain registration, and health checking. It also supports routing policies such as weighted, latency-based, and failover routing, allowing you to control which endpoints DNS returns based on the architecture you're trying to build. Then show that you understand where Route 53's responsibility ends. Route 53 helps determine which destination a DNS query receives. It does not replace the network path, security controls, or application availability required to make that destination actually work. If the interviewer asks for a real-world example, give them one. Suppose an application runs in two AWS regions. I could use latency-based routing to help direct users toward the region offering better latency. Combine that with health evaluation so unhealthy endpoints can be removed from eligible DNS responses, and choose TTL values with DNS caching and failover behavior in mind. Now you've gone beyond defining the service. You've shown that you understand how DNS, routing policy, health monitoring, caching, and application architecture work together. That's the difference between memorizing an AWS service and knowing how to use it. Next in this series, we're moving from DNS to content delivery with Amazon CloudFront. Route 53 helps users find the right destination. CloudFront tackles a different problem, delivering content closer to users through AWS's Edge network. We'll connect those two services in the next video. But before moving on, spend 20 minutes proving that you can actually use Route 53. Here is a safe 20-minute Route 53 practice session. First, use a test subdomain that you own and can delegate. For example, lab.example.com, or use an existing public test domain. Create a public hosted zone for that subdomain, Then add the delegation record in the parent zone so public DNS resolvers can actually find it. Creating a hosted zone without delegation is still useful for console practice, but it will not demonstrate public DNS resolution. Second, create two A records for a test name such as app.labexample.com, one primary and one secondary. Use public endpoints that you control, or choose a health check design based on a CloudWatch alarm if your workload is private. Route 53 endpoint health checkers come from outside the VPC, so they cannot directly probe a private-only IP address. Third, use failover routing, attach the health check to the primary record, and choose a deliberate short TTL. Test from a DNS tool such as DIG or NSLOOKUP. Then allow for health check evaluation and cached DNS answers to expire before expecting the secondary record. Finally, clean up. Hosted zones, health checks, traffic flow policy records, and domain registrations can create charges. Delete the practice resources when you finish and check current Route 53 pricing before you start. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.